good day everyone. I welcome you all to the group discussion of Team 7. So, I now introduce our topic. We have Chapter 11, the Mathematical System. But before anything else, allow me to introduce my team, the Team 7. We have Miss Daisel Lubguban, yours truly, Miss Lady Lu Peligro, and lastly, we have Miss Maria Shella Lopez. So we are the Team 7. And now, to formally start the discussion, let's first meet our learning objectives. So, after completing these chapters, the learner will be able to first, discuss what is modular arithmetic, 2. Perform operations at mathematical expressions correctly, 3. Perform the properties of congruence, 4. Find the least residue, 5. Application of modular arithmetic, 6. Apply mathematical principles in cryptography, 7. Articulate the importance of mathematics in one's life, 8. Know what is group theory, 9. Determine if a set is a group, 10. Know the 4 properties of a group and how to use it. Then lastly, we have to know the importance of group theory. So yes, guys, are you ready? So let's now move on to our discussion. So before we will going to really proceed to our main topic, which is the modular arithmetic, let's first find out what is division algorithm. So if you are confused while we are talking about this, it is because division algorithm is very important for us to know what is modular arithmetic, for us to solve or for us to get the congruence of such equation or such value. So yes, that's why I welcome you all to what is division algorithm. So division algorithm. What is division algorithm? So division algorithm is an algorithm which, given two integers, which is the and d, then you will compute their quotient and or remainder, then the result of Euclidean division. So that is division algorithm. So what is the result of Euclidean division? So Euclidean division, this is an arithmetic Euclidean division or the division with remainder. So yes, it is the process of dividing one integer by another in a way that produces an integer quotient and a natural number remainder strictly smaller than the absolute value of the divisor. So that is what we call the Euclidean division, that is why we can have division algorithm. It is because the result of Euclidean division. So once again, Euclidean division, this is the process of dividing one integer by another in which they can produce an integer quotient and a natural remainder. So we should always remember, take note this, that the number remainder must be smaller than the absolute value of the divisor. So yes, that's the rule. So we have here the formula for division algorithm for you or for us to really understand what is division algorithm and how to find or to solve this. So we have A equals congruency Q times B plus R. So Q there stands for the quotient, R stands for the remainder, A for the dividend, and B for the divisor. So we have here an example of division algorithm. So example, when we divide 17 by 5, we get 3 as the quotient, then we have 2 as the remainder, where A is equivalent to 17, which is the dividend, B is equal to 5, which is our divisor, then Q, our quotient, is R, which is the answer, then we have the remainder, the natural remainder, which is 2. So as we can see, the remainder 2 is lesser than the divisor, which is 5. So that is how we will going to compute the division algorithm. So to further understand, I have here some example. So here the formula since introduced the formula, we have A equivalent to QB plus R. So based on the picture I have given, the Q is equivalent to 3, the quotient, diba? Sa 17 by 5, the quotient, the answer is 3, divide by the divisor, which is 5, plus the remainder 2. So we have 5 times 3 equivalent to 15, plus 2, 17. So we have concluded that those equation is congruent. So that is why we now move on to modular arithmetic. I welcome you all to chapter 11, unit 11.1, the modular arithmetic, which is connected to the division algorithm. That's why I am introducing you first the division algorithm for us to know how to solve the modular arithmetic. Since modular arithmetic is, let's find out. So, what is modular arithmetic? So, modular arithmetic, it is a system of arithmetic for integers which considers the remainder. So, in modular arithmetic, numbers wrapped around upon reaching a given fixed quantity. So, this quantity is known as the modulus to leave a remainder. So, this section covers the properties and laws on congruence. So, diba, I have sa division algorithm, so I have already mentioned congruence. So, mo po na siya sa modular arithmetic. So, modular arithmetics, na-cover na siya sa properties and laws on congruence. So, nasabtan ra. So before anything else, let's just know who discovered modular arithmetic. So modular arithmetic was introduced by Carl Friedrich Gauss on the very first page of his magnum opus Arithmetical Investigations, or Disquisitiones Arithmeticae. So Gauss was one of the most brilliant mathematicians of all time. So this is Carl Friedrich. So mo na siya. So very handsome, no? So also, modular arithmetic is the arithmetic system for integers, again, constructed around the uniqueness of remainders given by the division algorithm. So, di ba, I have nasud ng division algorithm. So, more precisely, the equivalence relation congruence modulo n and the set of integers gives rise to n equivalence classes, and modular arithmetic is the arithmetic done in these equivalence classes. So yes, that is all about modular arithmetic. So at what I have said, modular arithmetic covers the properties and laws of congruence. So we were going to talk about congruence. So congruence, we have the formula. So the formula of congruence, we have A is congruent. So kaning tulo kani ka line that is congruent. So A is congruent to B mod M. Di ba? Mod is ang modulus. So we have let A be elements to Z, and M is element to N. So we say A is congruent to B modulo M, and write A equals congruent to A is congruent to B mod M if M L equal A minus B. So the integer is called the modulus of the congruence. So if A is not congruent to B, M, so we write A, ang sign is tulo ka line, then slash, then B mod M. So to further understand, I have here an example. So verify if the following are true. So the given is, di ba, atong formula is A congruent to B mod M. So the A there, we have 2 congruent to B mod 5. So ato siyang we will going to verify. So in order for us to know if congruence ba ang 2 sa B mod 5. So here the solution. So we use the division algorithm, di ba, nga way of solving. So 5 divided by 3, so we have 1. So 1 is the quotient, then 2 is the remainder. So we can see congruent sila. So 2 is congruent to 5 mod 3. So the answer is true. Another example. So 1 is 1 congruent to 10 mode 3? So let's see the solution. So 10, we have 10 divided by 3. We have 3 is the quotient. Then we have the remainder 1. So as we can see, 1 is congruent to 10 mode 3. So this equation is true. Next, we have the last is 2 congruent to 7 mode 3. So you have the solution. So as we can see, 7 divided by 3 equals 2. Then the remainder must be 1. But the given equation is 2. Or dili siya congruent. So that's why we put like 3 line and I slash. So ang letter C is not true or not congruent. So yes, nasabtan ba ang all? Kaya we will going to proceed. So that is all about congruence. Now, let's proceed to the least residue. So when we're going to talk about least residue, what comes after your mind? So from the word least means kinagamyan. So least residue, this is a system, is a complete residue system, and a complete residue system where it's simply a set containing precisely one representative of each residue class modulo n. So, for example, the class residue system of modulo 4 is we have 0, 1, 2, 3. So, dapat di ka malapas above 4 kay least residue man sa 4. So, imuha yung dalawang ana is ang less than or paubos sa 4. So, that is how we will going to, identify the least residue system. So, mo na siya. So, we have here an example. Find the least residue of the following. So, 11, mode 8. So, for you, what is the least residue of mode 8? Babe. So, yes. So, the least residue of mode 8 is we have from 0, 1, 2, 3, 4, 5, 6, 7. So, when we were going to divide, so we have 11 divided by 8. So, we get 1 as the quotient, then we have the 3 as the remainder. So, di ba? Sakto, 3. So, ang 3 is, makita nato sa aning sa iyang least residue system nga naa ang 3. So, ang least residue sa 11 mode 8 is equivalent to 3. Subtan? So, next. So, therefore, we can conclude that the least residue of 2 mode 8 is 3. Another example, 25 mode 5. So, we have here, as we can see, ang least residue sa mode 5 is we have 0, 1, 2, 3, 4. So, when we divide 25 by 5, we get 0 as the answer. So, the least residue, so we have the least residue of 25 mode 5 is 0. Another example. So, ato, para masabtan, para makuha po ninyo or for you guys to know how to solve also the least residue of a negative numbers or negative problem or something, I will give also an example. So, kay ganyan kay positive man. So, now, let's move on to negative. So, negative 11 mode 6. So, what do you think is the least residue? So, 11 mode 6. So, as we all know, ang least residue system sa mode 6 is from 0 up to 5. So, when we were going to divide this negative, so we have negative 11 divided by 6, we get 2. Kanong mag-as mo nganong 2 man na siya. So, the way of solving ani is musaka bitaw tawag number for us to get kanang positive result. Kay since negative man nagihatag, so musaka mi. So among nakuha nga answer is, di ba? Negative 11 divided 6, we have 2. So 6 times 2, 12. So we change the sign. So we have negative 12 nya plus na siya, di ba? Once man, di ba? O lahi gani ang sign. So nag-result lahi man siya sign, pero gi-minus man siya. So nahimo ragyapon siyang positive since pareha raman sila og sign gi-negative man nato. So we have 1. So the least residue of negative 11 mode 6 is 1. So, makita na po na to. So, always remember nga, every time gani nga mag-divide tog negative, ato siyang sakaan. Unsa ang mas dako, mas taas ana. So, for example, mag-divide nga ni negative 11. So, nisa kami. So, we have nakaget mi og 12 para makakuha ta og positive nga remainder. So, nasabtan ra. So, therefore, the least residue of negative 11 mode 6 is 1. So, yes, that's all about the congruence. So, now let's move on to the properties of congruence. So, congruence is useful because it can be manipulated like ordinary equations. So, congruences to the same modulus can be added, multiplied, and taken to a positive integer power. So, example for any A, B, C, D element and M and element to N. So here, so if A congruent to B mod M and C congruent to D mod M, then A plus C congruent to B plus D mod M, B A minus C equals B minus D mod M, or A times C congruent to B times D equals mod M. So dapat congruent lang sila bitaw, like equal or something equal. So we have also number 2. So if ang A ni congruent sa B mod M, then ang A to the power of N is congruent pud sa B to the power of N mod M. So if number 3 pod, other properties kuno, if A is congruent to B mod M, then NA is congruent also to NB mod M. Another property we have, if A congruent to B mod M, then FA equals congruent to FB for any polynomial Fn with integers coefficient. So, also we have, if A congruent, another properties is, if A is congruent to B mod M, then A equals congruent to B mod M for any positive divisor B of M. We have also number 6, reflexive, where if A is congruent to A, this is where ang reflexive congruent, purpose of congruent is ang A is congruent to A mod M. So number 7, symmetric, if A congruent to B mod M, then B is congruent to A mod M. Diba? Congruent. So lastly, you have 8, the transitive. So if A is congruent to B mod M, so ang B is congruent to C mod M, then ang A is congruent to C mod M. So yes, that's are the properties of congruence. So we have here an example. So evaluate each of the following. So A, 24 plus 39 mod 11. So we were going to add 24 and 39 to produce 63. Then we divide by the modulus 2. So the answer ay modulus 11. So the answer is the remainder. So we have here 63 mod 11. So, ang 63 divide sa 11, we get the quotient 5 and the remainder 8. So, ang 8 is congruent to 24 plus 39 mod 11. So, nasabtan. Another. 34 minus 16 mod 5. So, we have 18 mod 5. So, 18 divided by 5, we get 3 as the quotient, as the answer, then 3 ang remainder. So, ang 3 is congruent to 34 minus 16 mod 5. Another, 32 times 43 mod 14. So, as we multiply 32 by 43, we get 1,376 mod 14. So, 1,376 divided by the modulus for mod 14, then we get 98 remainder 4. So, 4 is congruent to 32 times 43 mod 14. So, yes, that's how we get the congruence and all about the congruence and the properties of congruence, which covers the section, or which covers the modular arithmetic. So yes, that's all about modular arithmetic. And now let's move on to the application of modular arithmetic. I hope you guys learned something. Thank you.